Hey everyone, Mr. Haddock here, and today before we start lesson 2.2, I would like to review with you what your atmosphere and weather notebook should look like. So underneath the table of contents, you should have the number of slides that yesterday's notes took up. Mine took up 2 slides, so I put 3 and 4. My notes also look like this. I highlighted the title of each slide, as well as bolded it and underlined it to draw out, making sure that I know that that's an important topic. I did forget a question mark right there. And these are the slides from yesterday. Now we're going to continue on with the slides from today. Today's slides are 2.2, composition of the atmosphere. And you will begin taking your notes again. Just a recommendation, I use size 25 font and I use Times New Roman text when it comes to taking notes. You do you though. You do whatever makes you happy and whatever will help you with studying these notes down the road and accessing them. So let's take a look at the composition of the atmosphere of Earth. Yesterday we talked about the types of gases that make up. We listed nitrogen, oxygen, and carbon dioxide, but I do want to go a little bit farther in detail with regards to the gases that make up Earth's atmosphere. You will need to know these percentages and gases, so make sure that you have these down and you study them. You are also more than welcome to screenshot or find a pie chart through Google to represent the gases, percentages, and things like that. But nitrogen and oxygen equals 99% of the air in the atmosphere. So the large portion of our atmosphere is nitrogen and oxygen. Nitrogen takes up 78% of the Earth's atmosphere, or makes up 78% of the Earth's atmosphere. Oxygen makes up 21%. Argon makes up 0.93%. And carbon dioxide makes up 0.04%. And water vapor is less than 1% overall. Now, in the lowest layer of the atmosphere, the troposphere, roughly 4% of the troposphere is water vapor. So the rest of the atmosphere does not contain much water vapor at all. So just be aware of that. Let's talk about water vapor a little bit more. So you guys, since we live in North Carolina, you understand humidity. You've heard the term. It's that stickiness feeling that you get in the summer. But humidity in a scientific context is the amount of water vapor in the air. So the higher the humidity, the more water vapor that is in the air. Humidity varies from place to place. Typically, areas that receive during the summertime have higher humidity because the evaporation rates are higher during summer because that part of the earth is receiving more direct sunlight. The more direct sunlight, the increase in evaporation of water, and that means that there's more water vapor in the atmosphere to give that to provide the humidity. Water vapor is created by evaporation, so it goes from water in our oceans to water vapor through the process of evaporation. And eventually, as the water vapor rises in the atmosphere, it begins to cool and it will condense and form clouds. The next thing I want to talk about are greenhouse gases. I'm sure that you've heard the term greenhouse gases, but you might not necessarily know what they are or what they do. So greenhouse gases trap heat in the atmosphere. Without greenhouse gases, it would be extremely cold during nighttime. So thankfully, greenhouse gases do trap heat and prevent nighttime from getting frigidly cold. The big greenhouse gases that I want you to know are carbon dioxide, methane, water vapor, ozone, nitrous oxide, or also known as laughing gas, and that big word down at the bottom are chlorofluorocarbons, or CFCs. Over on the right-hand side, you can see a nice graphic from the University of California, and you will notice it just kind of breaks down where do greenhouse gases come from, particularly from humans. So 25% of greenhouse gases come from electricity and heating, 20.4% come from the agriculture and land, 17.9% of greenhouse gases come from industry, 14% from transportation, almost 10% from other energy usage, almost 7% from food waste, and around 6.5% from buildings. So just an interesting little graphic there to kind of give you an insight into greenhouse gases and where humans put them into the atmosphere, where are the places that humans are putting them into the atmosphere. The next thing we need to talk about are particles in the air. So there's a vocab term that you need to understand, and that is particulate. A particulate is an extremely small particle. This could come in the form of dust, soil, salt, smoke, or ash. Sometimes they are microscopic to the point where you can't see. Other times they are a little bit larger where you can see them and they might block out, for example, smoke, right? You can see smoke. But other things you might not necessarily be able to see in the air because they are so small. Particulate and particles can pollute the air and be unhealthy to breathe, particularly in large quantities, but not necessarily, like it's not good to breathe in smoke and it's not good to breathe in dust and things like that. Our lungs were not designed to manage those types of things. But they're also extremely important. So there does need to be particles in our atmosphere, otherwise water vapor wouldn't be able to condense and form clouds. So the way clouds form is you have a water in a vapor form, in a gas form, and as it's cooling, it wants to condense, but it can't condense unless there's a surface that it has to be able to condense on. And water vapor, so when it finds a particulate in the atmosphere floating around, that water vapor latches on and is able to condense onto that tiny particle and turn back into liquid water, which when that happens millions of times forms clouds. So we do need particles in the air, otherwise we would not have clouds, and if we don't have clouds, there would be no rain either, which would be a bad thing as well. That is it for this lesson. Before you go, I do want to review, you guys have heard in the news and things like that about greenhouse gases being really, really bad. We do need some greenhouse gases. Greenhouse gases do occur naturally. They are not all human made. They're not all human emitted. They do occur naturally. So just be aware of that. Don't think that it's human sole responsibility for putting greenhouse gases into the atmosphere. Greenhouse gases come from volcanoes and other natural sources as well. So it's not just humans. Anyway, you are done with today's lesson or lecture, I should say. The next thing you have to do is read the Composition of the Atmosphere article found on Canvas. and answer the following discussion question that can be found on Canvas. How do greenhouse gases help life on Earth? The third thing you have to do is have a great rest of your day.